given by delta. The step length denoted by h. Then the forward operator, difference operator, is given by delta, which is given here, which is defined as in the next. What is the difference between the Lagrange formal method and the Newton's divided difference? The forward difference operator means x1 means x2. What is the difference between the present with next operators? With this formula, f of x plus h minus f of x defines the value of delta f of x. Hello everyone, it is Dr. Ravi Kumar YB, Department of Computer Science, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. In today's class, you will learn about some of the examples of Lagrange interpolation method and the Newton's divided difference method. In this case, you will learn about the Newton's divided difference formula and Lagrange formula. What is the formula to do this? We have the given data like this. That is, when x equal to 0, we have f of x is 1. X equal to 1, we have 3. When 3, we have 55. This is the data we have given from 1 to 3. That is 0 to 3. We have this data now. Now, what is the value of xi? 0. F of xi is 1. When it is 1, we have 3. When it is 3, it is 55. But between 1 and 3, we have 2. What is that? It is 26. Between 0 and 1, we have that value, that is 2. So this has to be followed here. Now, we have f of x0, which is a constant. F of x0, that is 1, plus x minus x0, then x minus x1, x minus x2, so on and so forth. So this is how it is going to be done. If that is the case, what is f of 2? What is f of 2? That is 21. How can I determine the value of 2? That is this. We have f of x1, we have formula called f of x0 plus this term. What is that term? F of x1 plus f of x1 into x minus x0 into x minus x2. It is x2. So if that is the case, we have the terms like this, which is multiplied by this term. Already it is multiplied. So we are going to have this. So what is the first term? That is f of x0, that is 1, plus what is x minus x0? 2 minus what is x0? That is 0 into 2 minus x2. What is 2? That is 3. 2 minus 3, that is 2 minus, yes, it is 2 minus 0 into 2 minus 1. It is 2 minus 1. Then what is f of x1? It is 8. We have this term. Now if I simplify this, 1 plus 2 into 2, that is 4. 4 into 8. We have this term. 2 minus 4. This term is considered here. What is the value of this? 1 plus 2 into 2. That is 2 minus 0 is 2. 2 minus 1, it is 1, not 2. So 8 2s are 16. 16 plus 1, it is 17. But we have the terms here like this. We have the terms like this. This is the case, x minus x0. What is x0? It is 0. What is the value of x? It is 2. We want to find the value of 2 here. Then f of x0 plus x minus x0 into f of x0. That is, if that is the case, what is the value of this? It is 2. So this has to be multiplied by 2. This is okay. This has to be multiplied by 2. So 2 minus 0 plus 2 into 2 minus 0. That is 2. That is, this becomes 4. So totally it becomes 8 to the 16, 16 plus 1, 17, 17 plus 4, 21. So this is the value of f of 2. That is, f of 2 is equal to 21. Oh, sorry, it is 2 is equal to 21. So if that is the case, let me apply the function f of x. X minus x1, x minus x2 divided by x0 minus x1, x0 minus x2 into f0. So this is the function. If that is the case, see to it. F of 2 is equal to 2 minus 1. What is the value of x? It is 2. What is the value of 1? x1, it is 1. 2 minus 3, it is minus 1. So this is followed. The same values are substituted here to get the values of this, that is f of 2 is equal to 21. There is another example with x equal to 0, f of x0 is equal to 1, 1, 14, 2, 15, 4, 5, 5, 6, 6, 19. So we have these terms here. If that is the case, let me apply the formula here. Newton's divided difference formula is defined by this term. That is f of x plus x minus x0 into f of x comma x0 comma x1. We have this term. Please be careful. Then we have x minus x0 into x minus x1 into f of x0, x1, x2. We have x0, x1, and then the next term, that is x2, is considered here. Similarly, x minus x0 into x minus x1 into x minus x2 into, we have the four terms here, x0, x1, x2, x3. We have then x minus x0 into x minus x1 into x minus x2 into x minus x3. We have three terms here, but fourth is also considered. So x1, x2, x3, x4. We have x0. All these terms are repeated here. So to get the fifth term, so f of 3 is equal to what? 1 plus 3 minus 0, that is x minus x0. What is the value of x? It is 3. 3 minus 0, that is x0, into 13. Plus 3 minus 0 into 3 minus 1 minus 6. If I substitute all these values according to this, 1 minus 1 plus of 3 minus, that is 3 minus 0, it is 0th term, right? So 0 plus 13 into 3 minus 0 into 3 minus 1 plus of minus, that is minus 6. So minus 6 into 3 minus 0 into 3 minus 1 into 3 minus 2. So this is done. Plus 1 into 3 minus 0 into 3 minus 1 into 3 minus 2 into 3 minus 3. That is the value. So if that is the case, see to it here. We have the terms like this, 3 minus 0, 3 minus 1, 3 minus 2 into 1. So totally that turns out to be the value which is equal to this term. That is, this is 3 minus 0 is 3. 3 plus 13 into 3 minus 3 into 2, that is to 6. 13 into 6, we have minus 6 into 3 into 2, 6. 6 into 1, 6, that is 6, that is 36. Plus we have 1 into 3, 3. First let me do this calculation. 3 into 2, 6, 6 into 1, 6 into 0, this becomes 0, 0 into anything, this becomes 0. So if that is the case, we have 3 plus 18, that is 21 minus 36. So what is the value I am going to get? That is 21 minus 36, that is 15. I have to get the value 15. In this case, it is minus 15. So what is the value I am going to get? See to it here. It has to be 15 here, minus 15 here for the value of f of 3. If that is the case, see to it here. This is by Lagrange interpolation formula. The continuous thing till here. If you substitute those values into this equation, into this formula, what is the value? 3 minus 0, 3 minus 1, 3 minus 4, 3 minus 5, 3 minus 6 divided by 2 minus 0, 2 minus 1, 2 minus 4, 2 minus 5, 2 minus 6. This is obtained for the third term. This is for second term, third term. This is for fourth term, and this is for fifth term. This is for sixth term. So totally we have 6 terms. After simplification, we will get the value f of 2 is equal to 10. Then find the value of f of 0.25 for this equation. That is this. 0.5, 0.1, it is this. 0.2, it is this. 0.3, it is this. 0.4, it is this. 0.5, it is this. So we have these terms here. So 0.25 is to be determined. 0.2, 0.25, in between these two. So 0.25 is to be determined. How can I determine that? That is, Fi is given here. So Newton's divided difference. What is the formula for finding the Newton divided difference formula? That is this, f of x0 plus x minus x0 into f of x0 comma x1 plus x minus x0 into x minus x1 into f of x0, x1, x2. We have these terms plus, yes, we have the terms x minus x0, x minus x0, x minus x1, x minus x0, x minus x1 into x minus x2 we have here. So if that is the case, into f of x0, x1, x2, x3 is considered here. So this is the formula. So if I write down like this, f of x2, till here it is over. Yeah, it is over here. Let me rewrite the same equation for this, for the entire thing. So if that is the case, plus we have x minus x0 into x minus x1 into x minus x2 into, continues here from here to here, x minus x3 into f of x0, x1, x2, x3, x4. All these are the terms going to be used now. What is f of x0? See here. What is f of x0? 9.9833 plus x minus x0. What is the value of x here? 0.25. 0.25. It is 0.25. What is the value of x? It is 0.25. So 0.25 minus x0 means 0.1. This term is to be multiplied by f of x0 comma x1. What is f of x0 comma x1? This is x0 is this, x1 is this. So we have the terms like this. If that is the case, what has to be done here? See here, 0.25 minus 0.1 minus 50.166. 50.166 is where it is here. So this has to be multiplied by minus 50.166. So if I write down this further, what happens? 0.25 into 0.2, 0.25 into 0.3, then it is multiplied by 166.675. That is 0.25 minus 0.1 into 0.25 minus 0.3 into 166.675 plus next term 0.25 minus 0.1 into 0.25 minus 0.2 into 0.25 minus 0.4 into this term minus 41. If this is minus 41, the entire thing becomes 41 minus thing. So this is 416.68. We have three terms here. First term here, second term here, third term here, fourth term is to be defined again. Which is that fourth term? That is x minus this term. That is 0.25 minus 0.1 into 0.25 minus 0.2 into 0.25 into 0.3 into 0.25 minus 0.5 we have. Then we have the terms like this, 833.42. 833.42. If I simplify all of these terms, this equation, I will get the value which is equal to 3.912. That is this, which is equal to 3.912. That is by Newton's divided difference method. That is 0.25. F of 0.25 is equal to, this is by Lagrange method. This is by Newton's divided difference. F of 0.25 is equal to 3.912. So this is the formula we are going to apply. Next we have the Lagrange method. What does the Lagrange formula indicates? The same thing. If you apply these values into this formula, you will get the value f of 0.25 is equal to 3.912. But what is the difference between the Lagrange formal method and the Newton's divided difference? Let me show you here. But of course, we are getting the same value. We are yielding the same result. See here, that is 0.25 minus 0.2, 0.25 minus 3, because 0.1 is skipped here according to the formula. Then 0.25 minus 4, 0.25 minus 5 divided by those terms into 9.9833. Plus this term is calculated. Now 0.2 is skipped here. Please see here. This is multiplied by that value given in the table. Then 0.3 is skipped here. Then 0.4 is skipped here. 0.5 is skipped here. If I do these operations, finally I'll be left with f of 0.25 is equal to 3.912 by Lagrange method. That is by Lagrange method. The same value is applicable for the Newton's divided difference method. So we have the difference operators like this. We have already seen difference operator called divided difference operator. We define few more difference operators and their properties in this section. That is forwarded difference operator. What is the meaning of forward difference operator? The forward difference operator means x1 means x2. What is the difference between the present with next operators? Next term. So function f of x is given by is spaced equally distributed, discrete. That is point say x0, x1 to xn, f of 0 to xn corresponds to, where f0 corresponds to x0, f1 corresponds to x1, so on up to fn corresponds to xn. So we have all these terms respectively. So I am using the word respectively here. Also, let the constant difference between the two consecutive points of x is called as the interval of differencing. That means between f0 and f1, what is the difference? That is given by delta. That is given by delta. The step length denoted by h. Then the forward operator, difference operator, is given by delta, which is given here, which is defined as in the next. That is f of x plus h minus f of x. That is delta f of x. That is what is the difference between this and this. Difference is indicated by this. That is delta f of x is equal to this method. See here, f of x plus h. What is the step size of that? X plus h. That is f of x plus h. What is the step size? This is called as a step size. Difference between the present and the next term. Minus f of x. That is the present. This is the next term. That is minus f of x. So what is the value of this? This gives me the value of delta of x. So typically, which is given by this formula. So fi is equal to this term, the same thing. We have similarly the higher differences. Delta of x, that means delta square f of x. If that is the case, we have f of x plus h, then f of x is considered, whose difference is considered here. That is f of x plus 2h minus 2 times f of x plus h into f of x. If I further simplify this equation, this becomes fi plus 2 minus 2 fi plus 1 plus fi. So we have 3 fi here, or in general we write it as, in terms of general terms, higher order terms, difference, that is forwarded difference, that is obtained by delta n f of x is equal to delta n minus 1 delta f of x, which is equal to delta n minus 1 f of x plus h minus delta n minus 1 f of x. The same thing is written here to indicate that what is the degree of difference, forward difference for higher order. So this is how we are going to calculate that. The forward difference can be calculated for the function x equal to 4. This is to be calculated. What is the initial value? 0, 4, 7, 4, 43, 8, 367. Then find out the forward difference of the function. This is called x0, x1, x2, y0, y1, y2, also called as f1, f2, f3. What is the value of this? 4. What is the value of this? This has to be determined. So if that is the case, what is the value of this? F of x plus h is what? What is the difference? 0 to 4 is 3. 4 to 8 we have 4. So we have the term called as f of 4 plus h. H is 4 here. So 4 plus 4, 8. F of 8 minus f of 4, that leads to the term. What is f of 8 here? What is f of 8? 367. So 367 minus, what is f of 4? What is f of 4? It is 43. It is 43. Same thing, which yields to the value which is equal to 324. So this is the value of 324. That is f of 4. Delta 4. F4. This is how we are going to calculate. For the function x2 plus, that means x square plus 2x plus 3 is the function. X square plus 2x plus 3 is the function. That is f of x equal to this. Now for this, what is the step size? H. We want to find out that. How can we find out that? That is with this formula, f of x plus h minus f of x defines the value of delta f of x. So if that is the case, delta f of x can be determined with the help of this x plus h. So x plus 2 whole square plus 2 times x plus 2 plus 3. I'm substituting the x plus 2 into this term. 2 times x plus 2 plus 3 minus, this is for x plus 2 minus the original equation, x square minus 2x minus 3. If I further simplify this equation, what happens? X square plus 4 plus 2 times x plus 2, that is 2x plus 4. This becomes 2x plus 4, that is 2x plus 4. If I further simplify this term, this becomes 2x plus 4 plus 3 minus x square minus 2x minus 3. If I further simplify these terms, how many x squares are there? Plus x square minus x square get cancelled. 2x, 4x. I have plus 2x minus 2x here, plus 3 minus 3 here. So we have the terms left with, that is 4, 4, 4. That is, yes, that is the term. 2x we have here, 2x plus 4 plus 4 plus 4. We have 12. So we have the terms like this, 2x plus 12, which is equal to, we have the terms like this, x square minus x square. Those gets cancelled. We have, oh sorry, it is 2x, it is 4x. So we have 4x here, 4x plus, this gets cancelled, this becomes 8. So sorry, this is 4x plus 8 here. This is 4x plus 8. If I further simplify this term, let me rewrite this term once again. That is x plus 2 whole square can be written as x square plus 2 square plus 2 times 2x. That means this becomes 4x. This becomes 2x plus 4 plus 3 minus x square minus 2x minus 3. If I simplify these terms, what happens? Plus x square is there, minus x square is there. 2 is what? 4 plus 4x plus 2x. 2x minus 2x gets cancelled. So let me not rewrite this. 4 plus 3, 7. 7 minus 3. 7 minus 3, again it is 4 we have. So 4x plus 4 plus 4, that is equal to 4x plus 8. This is the value we are going to derive for this. The same thing is mentioned here, 4x plus 8. If that is the case, we have the second difference, that is delta square f of x. That is, we are going to consider this now, 4x plus 8. This is the equation going to be considered for delta square x. This has to be differentiated from this with this, x plus 2. If that is the case, what is that? 4 times x plus 2 plus 8, that leads to 4x plus 8 plus 8. That means 4x plus 16. Am I getting the same term? Oh, that has to be subtracted. Yes, correct. 4x plus 8 minus this term. 4x plus 8 is this, 4x minus 8. So we have this term like minus 4x minus 8. If I add this term, plus into minus, that becomes minus. we have a plus here, we have a plus here, but minus into plus, this becomes plus. Minus into plus, this becomes minus. So the entire thing is brought here, 4x plus 8. Now if I further simplify this term, I will get the value 4x plus 4x plus 4x minus 4x. We will be left with 16 plus 8, it is 24. It is 24. Am I getting the value, same value here? That is 8. We have plus 4x minus 4x, the left with 8. Yes, it is 8. It is 16 here. So let me rewrite this term. 4x plus 8 is the term we have got here. 2 times, what is that? 4x plus 2, right? So 4 times x plus 2 we have got, plus 8 is the term we have applied here, minus of 4x plus 8. If that is the case, we will be left with 8x plus 4 plus 8 minus 4x plus 8. We have the terms here. 4 to the 8x, it is x plus 4x plus 2. 4x plus 8, it is 4x plus 8. 4 times, what is the value of x? It is x plus 2, 4x plus 8 minus of 4x plus 8. We have this term, 4x plus 8 minus 4x plus 8. We are left with minus 4x plus 8. This becomes minus, so minus. We are left with 8. So we are left with 8 here. So for third degree, we have 8 is the value we have. 8 minus 8 leads to 0. So we are getting this term in the third difference. So the properties of this include, difference operator includes delta f of x plus g of x equal to delta f of x plus delta g of x. This is the first property. The next property is delta c f of x. This is a constant term. I am multiplying with delta f of x, which is obtained in the previous thing. Now we have f of x. If f of x is a polynomial of degree n, then this can be written as this summation, where summation indicates a0 x1 plus a1 x1 plus a2 x square. This is a polynomial, so we are going to add up these terms plus a constant term, f dash of x, that is delta difference of nth degree into f of x, that is going to be determined. Proof of the first property, that is this property is given here. That is for, this is not in your syllabus, that is the terms like properties are not there in your syllabus. Other things are there. So let me anyhow explain you this. That is f of x equal to a0 plus a1x. We have delta f of x. What is delta f of x? That is difference equal to a0 plus a1 into x plus h. That is the formula being written here, minus a0 minus a1x equal to a1h. That is equal to a0 a1x, a0 plus a1x plus ah minus a0 minus a1x. This leads to what? A plus a1x minus a1x, a0 a0. We are left with a1h. That is the value we are going to get, a1h1. So this is the formula. So if that is the case, we have found that the value f of x equal to summation I equal to 0 to n a1 x bar I. So this is how we are going to calculate. My dear students, let me take you to this further discussion. Delta n f of x is equal to delta n, where f of x equal to a1 xi. This is further derived as this term like this. Delta n f of x equal to delta n. What is this? This is the present term minus the next term. So if I further simplify this, that will leads to 0. an delta n xn, that means an delta n xn, that is the formula value I am getting. An delta n, if I further take this, an delta n minus 1 x plus h bar n minus x bar n, that is the next term. If I further simplify this, an delta n minus 1, so on, like a 3 plus 2 plus 1, so on till 1. This is how it is going to be done. This is nth degree, n minus 1th degree, n minus 2 degree, n minus 3 degree, so on till h. So this is how we are going to calculate, where g of x is a polynomial of degree less than n minus 1. So if that is the case, n into f of x is equal to an delta power n minus 1 into n into h xn minus 1. If I further simplify this, this leads to the value n factorial into h power n. This is the value we are going to get. The difference operator, this is called as a gradient. This is called as a gradient. If that is the case, we have gradient of f of x equal to f of x minus f of x minus h. Earlier we had f of x plus h minus f of x. We had this earlier. Now we have for gradient, this is for this. For this, f of x equal to f of x minus f of x minus h, x plus h. Yes, we have the minus term here. We have the minus term here. So if I rewrite this term as fi is equal to fi minus fi minus 1 is called as backward difference operator. So we have a backward difference operator like this. This is for forward difference operator. So that is the second degree of the backward difference operator is this. If I further simplify this operation, I will get so on like that. That is delta 3. Furthermore, we will get this delta 3, delta 4, so on till it reaches to 0. This is how the difference operator works. We have the difference operator delta is given by this. This is called as a central difference. Suppose if I have one of the term here and another term here, what is the central difference here? We have 6 here. So the forward difference, for the forward difference, I will consider this term and this term and this term next time. For the backward difference, I will consider this and this first, this and this next. So that is called as a forward difference and backward difference. What is the central difference between 5 and 6, 5 and 6, 1 and 5? That is called as a central difference. Central difference is indicated by this symbol. So we have f of x, that is delta f of x equal to f of x plus h by 2. Please be careful when you are using the central difference. We not only consider the h, which is considered as h by 2, step size by 2, minus f of x minus h by 2. So the forward as well as backward is considered here, so that the delta f of x is equal to f of f1 plus 1 by 2, fi plus 1 by 2 minus f of I minus 1 by 2. So if that is the case, this is called as a central difference. So second order, that is equal to this, and finally that leads to the term equal to fi plus 1 minus 2 fi plus fi minus 1. This is the second central difference. This is the first central difference. This is the second central difference. Further, if you simplify this, this option for further, you will get third central difference. This is how it is going to work. Next, we have a shift operator and averaging operator. This is the formula for shift operator. This is the formula for averaging operator. Relationship between these operators. That is this, E is equal to 1 plus delta, which is given as 1 plus delta. En, that is error, En fi is equal to summation k is equal to 0 to infinity n to 1 limits delta I fi. So this is the one which I am using. For n is equal to 1, I will get this term. For n is equal to 2, I will get another term. So on up to n is equal to some value, m or some value. RHS is defined by this, that is by adding up all these values, that is plus second term. When n is equal to 2, I will get one more term, e to the power of 2 f2 into 1 plus delta fi, that is f2. So this is going to be added. This is going to be added. So that is the one which I am using for n is equal to 2. So we have the RHS like this. Then we have the result of this operation which I am discussing right now, that is this. Thank you very much. Thank you one and all. If you have any doubts or questions with respect to the Newton's forwarded difference and the Newton backward difference, then the Lagrange formula, then finally we have central difference formula, all these discussions have been done in today's class. If you have any questions with respect to the topics I have discussed, kindly come back to me during the live session or during the class hours so that I can give you the clarification about the doubts and questions which you have. Thank you very much. Thank you one and all.